Okay, in this short video we're going to look at the concept of z-value. If x is a data point in a data set, then the z-value measures how many standard deviations away from the mean that x value is. The z-score is how many standard deviations is away from the mean. If x is less than the mean, then the z-score will be negative. If x is greater than the mean, the z-score will be positive. Just for some quick reminders, you already know this, but when we're talking about a sample, if we are talking about the mean, then we use x bar to represent the mean. Whereas in a population, we use Greek letters usually, and the Greek letter that we use for mean is a mu. It looks like a U with the long tail here in the front. The standard deviation in a sample, we use the letter S. In a population, we use the lowercase Greek letter sigma. In each case, we'll use X to represent a data point. Now, with that notation, then it means that when we're talking about a sample, if we're looking for the z-score, then z is going to be the x value of the point that we're trying to find the z-score for, minus the mean, x bar. That tells us how far x is away from x bar, and all divided by the standard deviation. That means that we count how many standard deviations away it is. In a population, the words are the same. See, x minus the mean divided by the standard deviation. X minus the mean divided by the standard deviation. Let's look at a quick example. Suppose that we're looking at a sample, and in the sample we know that the mean happens to be 45. Somebody's done that calculation for us. They've added up all the scores and divided by how many there were to find the arithmetic mean, and they've also done all that calculation to find the standard deviation. You've been learning how to do that, and let's say the standard deviation was 7. Now, if we're looking at a particular x value, let's say we're looking at the value 59, and we want to find out what its z-score is. The z-score for that will be the x value minus the mean divided by the standard deviation. So in this case, 59 minus 45, let's see, that's 14 divided by 7. So the z-score for 59 in this data set is 2. Okay, so it's kind of a way of ranking the data, like percentiles or quartiles, but instead it tells you how many standard deviations away from the mean any particular point is. That's the idea.